Hello everyone, greetings to all of you and welcome to today's class. We have to look at ideal gases. Yes, so in looking at ideal gases today, um, we will have to first of all define what we mean by mole. We'll also define the Avogadro. Yes, then we are going to look at the type of gases. We are going to speak of two, the real and the ideal gas. Let's get started. So first thing first, what is a mole? A mole. One mole is the amount of a substance that contains as many elementary particles as there are carbon atoms in exactly 12 grams of carbon 12 isotope. Alright now guys, the next thing is when we talk of the mole, the unit of the mole is mole. And then now the next is Avogadro constant. It is represented L and sometimes represented Avogadro number like this, Ne. Now the Avogadro number is numerically equal to 6.02 times 10 to the 23rd per mole. So the Avogadro constant is numerically equal to 6.02 times 10 to the 23rd. Okay, it is defined as the amount or the number of particles in 1 mole of a substance. So what does it mean? 1 mole of let's say, okay, for example, let's just take some good examples. One here, I said 1 mole of carbon 12 contains Avogadro number of carbon 12. 1 mole of helium 4 isotope contain an Avogadro number of helium 4 atoms. So that's just it, what you need to retain. Now many gases, they do not exist as single atoms but as diatomic molecule. We have example, the hydrogen gas, oxygen gas. They exist as, for example, hydrogen exists as H2. So as a result, 1 mole of hydrogen will not be 6.02, but in this case will now be 6.02 times 2, which is 12.04 times 10 to the 23rd. We'll take an example. Calculate the number of atoms in and the mass of the following. So first of all, we have ozone. Ozone is O3. This is ozone. We need to first of all calculate the number of atoms in ozone. Now, I want you to know that 1 mole of ozone will contain an Avogadro number of molecules, which is 6.02 times 10 to the 23rd. Okay, so good. As a result, ozone is O3. Good. So there are 3 oxygen atoms in ozone. If you take 3 times 6.02 times 10 to the 23rd, you should have 18.06 good times 10 to the 23rd atoms. You can approximate this to 18.1 times 10 to the 23rd by rounding up atoms. So this is the number of atoms in 1 mole of ozone. All right, now the mass of ozone. Mass of 1 mole of ozone. Ozone is O3. Mass of 1 mole of a substance is the molar mass of that substance. So here is just 3 times what? 16. It gives you what? 48 grams. That is the mass. All right, in B, they say 3 mole of water. Water is like this, H2O. Now, each molecule of water actually contains 3 atoms. Each one molecule of water contains 2 hydrogen, good, and 1 oxygen. All right. So now, when we talk of 3 water mole 3 moles of water, it means here now we're going to have 6 and here we're going to have 3. Okay, so that's good there. Now we are calculating the number of atoms in 1 mole of water. That should be 3 times. Then now the Avogadro number 6.02 times 10 to the 23rd. This should give us 18.1 times 10 to the 23rd atoms. So now, what now will be the number of atoms in 3 mole of water? We'll simply have to multiply this by 3. When you put this times 3, you're going to have 5.4 times 10 to the 24 atoms. Now we need to calculate the mass of 3 moles of water. Now 1 mole of water has the mass of, we have water is like this, hydrogen 1 times 2, then oxygen 16. This makes 18. 1 mole of water has a mass of 18. 3 moles of water have 3 times 18. So therefore a mass of 54 grams. That we're done. Now the next question says, the mass of 1 mole of hydrogen has gas is 2 grams. Calculate the mass of 1 hydrogen atom. So that's so good. 1 mole of hydrogen gas contains, let's calculate number of atoms, contains, because hydrogen gas is like this, so it's 2 times Avogadro number. Okay, so that done. That's the mass of the number of atoms 1 mole of hydrogen gas actually contains. Now, but the mass of 1 hydrogen atom. So I have the mass of 1 hydrogen atom. Now we are going to take 2 divided by this. Then that's going to give us 2 divided by, when you take this, we'll put 2 times 6.02 times 10 to the 23. Okay, so good. So if you divide this, you should have something like 1.6 or 1.7 times 10 to the negative 27 kilogram. So that's it, and that ends the equation there. All right, so now we are going to look at the equation of state, ideal gas. Okay, so the ideal gas equation is this equation: PV equal to nRT. PV equal to nRT. In this equation, R represents the molar gas constant, and the molar gas constant is equal to 8.31 joule per Kelvin. Good. So that is the ideal gas equation that is applicable in solving ideal gas problems. So here now we have Brownian motion. They are not really important according to your syllabus. So I'm going to end here. This is another example, still using the ideal gas, the ideal gas equation. So we are going to end our lesson here, and I'm going to leave you with test yourself section. Now you can see the question here. You can read the question, test yourself, and then where you have challenges, you submit. You can ask your question in the comment section as usual. Bye.